Okay, so we will have our second exam on next Monday, right? So here we just have a quick review for this exam. So this exam is about we say one sample problem. Okay, one sample problem. So once we have a data, one sample data, what we can do? Usually we can do two things. One is turn off. One thing is estimation, and the other is hypothesis testing. So we just have these two kinds of problem: estimation and hypothesis testing. So the foundation is sampling distribution. Right? If we take a sample, then the sample mean will follow this normal. Okay, so we say this is the most important, very important thing. X bar follow this normal. Okay, so because this is normal, then we can find some probability, right? So in this exam, we will rely on this normal table, Z table, and we also have the T table, right? So because like if we don't know sigma, we will have to check a T table, right? So we will we have to know how to check Z table, T table. So we should understand them. Okay. Okay. So we say those are basic things about basic preparation for this exam. Okay. Sampling distribution and Z table, T table. Okay. So for estimation, actually easy, right? We wanted to find a confidence interval for this population's average. So population's average can be mu, or can be p, or can be proportion. So proportion is a typical case, typical case for mu, right? So if data is those 1 0 data, we say 1 0 data, then this average is percentage or proportion, right? So here only thing a little bit confusing us is Z star or T star. So this star T star depends on this is sigma, the standard deviation sigma or ACE. If standard deviation is from sample, so we should use T, right? So how can find this Z star, T star? We need to check this Z table, T table. So this T star or Z star is quite the same. So only thing Z star, we get this Z star from Z table, right? So let's say, for example, we want to find 90% confidence interval. So this is so here's 0, right? So this is Z star or T star. So Z star means we need to check Z table, find this cutoff point. So for Z table, we say the table they usually give us cumulative all the way down. So all the way down means if we confidence interval is 90%, then we need to check all the way down should be 95%. So we should check 0.9500, right? We need to check the cutoff point for this probability. So we check from the table, check the neighborhood, find this cutoff point. Okay, so if this is T star, so T star, So T star story is quite the same. Okay, so suppose there's a T table, there's 0, so we want to find 90% confidence interval. So this is a T star. Okay. So for T star, we find this cut point. We just say, oh, one tail this side, one tail is 005. So we just check one tail 005 or two tail 0.10. Right? So for T distribution, we have a degree of freedom. So for one sample problem, degree of freedom is A minus 1. Okay? So from so once we have this star, T star, this is just some calculation, right? Okay, easy problem. Yeah. Okay. So in the exam, maybe we have such a problem. Find a confidence interval. Suppose the confidence interval is A to B. So what is A? What is A value? What is A value? Or what is B value? Right? So I give you A, B, C, D 4 choices. So you find you just pick a closer one. Okay. So those are estimation, confidence interval, easy, right? Okay, so for testing, so testing is, so here HO, we say HO is always equal, non-hypothesis means no difference, means equal. So some people say mu equal this number, or proportion P equals this number. Or if they say at least equal, like GPA, at least equal 3.0. So here HO, we just set as equal, right? So HO is always equal. So HA depends on HA depends on what good or bad meanings. So the story usually like some people say something good, we believe not so good. So sometimes good is one side, like for GPA, a good means one side, the high, the better, right? So excuse me. So for those testing, we call this a one side or one tail test. So sometimes, like if we're talking about cost, so then good means for us maybe cost is small is good, right? So we just check one side. So sometimes good means size is good, like for our people's weight, weight too overweight not so good, and underweight also not so good, right? Over blood pressure, same story, right? So in those cases, we need to check. We say two-tail test. So this is one tail, two tail. So if there's two tail, we say H not good means not equal. Equal means good, right? So not equal. P mu not equal this number means not so good. So for testing, we just wanted to find the difference. Like, okay, some people say mu here, mu 0, mu here, but our sample means here x bar, right? So we just need to check so their difference is big or small. So at the first, we just like changing general normal to standard normal. We just changing this to 0 and this number, so x bar to this. So this number is we call test statistic. Okay, test statistic. So sometimes we call this test statistic as z value. Sometimes we call this t value. So it depends on depends on which table we will check. If z value, we will check z table to determine that those number close or not so close. Right? If there's t value, we need to check a t table. So again, here's how can we know this is z value or t value? So determined by sigma or s. So formula quite the same. This is x bar minus mu 0 divided over sigma over radical n or s over radical n. Formula quite the same, right? Okay, so once this is z value, so we need to check z table to determine that difference big or small. So so how can we determine that difference big or small? So we can use two methods, two ways. One way is find p-value. Okay, find the p-value. So let's say if this z value, so here 0. Okay, so we have a cutoff point. Then so this is z table, right? So p-value is this probability, right? So here, if there's one tail, so just check this probability. So here, p-value also depends on one tail, two tail. If two tail, remember we need to multiply by 2, right? Yeah, if we have a cutoff point here, so p-value should be this side and also this side, multiply by 2. So 2 tail, 1 tail. Okay, so if this is standard normal, then we can find exact or find those probability. So if there's t value, then from t table, maybe we cannot find exact p value. So we can only say, oh, p value is in some range. Because the t table give us only some cutoff points. So we just let's say if there's a t table, so we know. Okay, so this star. This test statistic. So for t table, give us those points. Here, let's say here 005, the cutoff point is 005, and this is 0025. Okay, so then we find the p-value is between 005 and 0025, right? Okay, and the other way is find critical value. The critical value is, let's say, so other way is, if we wanted to determine this difference big or small, or this giving numbers big or small, let's say, suppose we have this question, we have this number is this, suppose this number is negative 1.56, suppose this. So we want to determine this is a big number or small number. So to answer this question, we just need to find the critical value. We want to find a critical value, right? So how can use this critical value? We can determine this. So suppose critical value is negative 1.20. So use this as standard. Then we can say, oh, then this negative 1.56 is big. Or we can say, oh, that difference is big. So how can find this critical value? So we need to check a table from sometime from z table, sometime from t table. So the critical value from z table, we call this as a z critical value. If this number is from T table, we say this is a T critical value. So how can find this critical value? We say depends on alpha. Let's say we want to find the critical value, so 1 till 005. Suppose alpha is 005. We want to find critical z critical value. Okay. So if we this side, so this means like this is 005. So this is a z critical value. Okay. So if this side, okay, so here now then like this 005, right? So we want to find this cut point. So this is the critical value. So T critical value same thing. Like suppose like a T alpha 005, we want to find T critical value. So only difference is suppose like we want to find this critical value is 005, alpha 005. Find this. So this is just like a T star, right? 1 till 005. So for T, so we need to check the degree of freedom, right? Determine degree of freedom, so find this critical value. So we use this critical value to determine the test statistic, that value is big or small. So if that number this is z value or t value, this test statistic is big, then we can say, oh, the difference is big. Or then we can say, oh, their claim mu equals this mu 0 is not true, right? Okay. And also, if alpha equals 005, but we also need to check like a 1 tail, 2 tail. So here's 1 tail. So how about a 2 tail? Like suppose alpha is 005, and we know there's a 2 tail. So 2 tail means like we need to check like a 2 tail, so 2 tail 005. So actually this becomes 0025, 1 tail, right? So when we need to check a 2 tail, so when the HA is not equal, means like not equal or not close to that number means bad. So we need to check both sides, right? So 2 tail. So 2 tail, so like here, 1 tail 005 or 2 tail 005. There's a difference, right? So don't get confused. Okay, so there's a critical value depends on alpha, also depends on 2 tail or 1 tail, right? Okay. Okay. So for testing, make our decision. So here we say once we have a cut point, we can make a decision. So we have those kind of problem. Like once we use this decision-making rule to make a decision, how much chance we may make a mistake. So here we have 2 kinds of mistake, type 1, type 2 error. So what is type 1? So we can say type 1 error is for other people's claim, our first reaction is refuse, right? We do not believe. But sometimes do not believe is wrong, right? So such mistake is a type 1 mistake. So instead, type 1 is just refuse HO when HO is true. Okay. So type 2 error is we for other people's claim, we easily to believe other people. We easily to accept their claim or easily believe other people. This is type 2 error. So instead, this is just accept HO when H was not true. Okay, so once we have the decision making rule, now once we have a cut point, then we can find alpha, and also sometimes we can find beta. Right? So basically we will check whether this decision making rule is okay, is good, or can we use this decision making rule to make our decision, just like that, right? Okay, so those are materials for this exam 2. So now let's check some sample problems. Okay, so first one, check Z table, T table. So this is the basic things. So don't make mistake for solve the problem. Okay, so like if we want to find critical value or find Z star T star, those things just based on this, right? Check Z table, T table. Okay. Okay. So let's say like for those problem, like for C, is this, so we want to check like is this probability less than 0.005, or so we just need to find what is the cutoff point, cutoff point such that the probability is 0.005. So let's say here so here we have negative 1.4. So we just check this. Let's say what is this probability? So we don't know. So how about this one? We just check this cutoff point or critical value, like just a critical value. Okay, this is 0.005. So what is this number? What is this? We put the T star. What is that? So this degree of freedom is 17. So we just check 17, right? So we say 1 till 0.005. So from table we can find this number, 1 till 0.005. So this 1 till 0.005. Okay, so then this number just the negative of this number, right? So we can compare. Okay, so suppose I don't know what this number is, so we need to check the table. So if this number, let's say, is 1 point negative, suppose this is 1 point, I don't know, but I assume if this number is 1.72, then this should be negative 1.72, right? So what does this mean? This means this is 0.005, and our cutoff point is here negative 1.42. Okay. So we say, oh, negative 1.42 is this probability is larger than 0.005, right? Okay. So this is just check a table. Okay. And so sampling distribution, we say like find the probability that the sample mean is between this. So this problem is just like x bar. We want to find this probability. X bar will be between 2.51 to 2.71. So what is this probability? So in order to find this probability, so we need to know what is the distribution for x bar, right? So x bar follow this normal. Mean, I just use this formula, okay? So we just check it here. What is mu? Okay. Oh, sorry. Okay. Okay, what is mu? So mu, let's see. Oh, I should I'm sorry, I should put this outside. Yeah. Okay. Ah. Okay. Okay. That's good. Yeah. So mu. So we just check. Okay. Mu is. So what is mu? Mu is 2.61. So what is sigma? Sigma 0.5. What is n? So take a sample size 36. Right? So x bar follow this normal. Then we can find this probability. Okay. Right? Okay. So for estimation, so let's say we want to find 95% confidence interval for mu. So we have the formula. Let's say x bar plus minus. So here is Z star or T star. So we have this formula or this formula. So at the first, we should determine which one. Okay. So to determine which one, actually we just check this sigma standard deviation. So we just check problem. Okay. We take a sample, so sample size. So n equal 50 sample size from, and sample mean 19. So x bar equal 19. And the standard deviation says. So this standard deviation is sigma or s. So we just judge it from the problem itself. It says that from the sample, we find this, find that, find the mean, find the standard deviation. So this is from sample, right? So this is S. S equals this. Okay, so we know we should use this formula, right? So then this problem quite simple. X bar 19. Okay, plus minus T star. T star we need to check from T table. A 6.8. So n 50. So what is T star? So T star, so just let's say T star is this cutoff point such that there is 95% confidence, 95%, and this is T star. Okay, so let's say this is 95, so outside two tail, so we just check two tail 005, right? Or one tail 0025, so we just check two tail. 005, right? And then what is the degree of freedom? So degree of freedom is 49 n minus 1. But from the T table, no 45. So we just check a table. I think we just check 40. Okay, because the table. The T table do not have 49 degrees. So here, if we cannot find exact one, so we just find a closer one, right? Always like that. So then such a problem easy. So this problem quite the same. We want to find 90% confidence interval for this. So similar problem, right? So at the first step, we need to check which formula to use. So here, let's say from sample, so we find sample mean, the sample size this, and the sample mean 12. Okay, and the standard deviation. So here's the key point: 2.5 is sigma or S. This is S, right? So judged from the problem itself, it says from sample we find this. Okay, so this problem quite the same as this as problem A, right? Okay. So for this problem, we want to find 92% confidence interval for proportion. So for proportion, we just use the formula p hat plus minus z star, right? So proportion, so no t star or z star, just z star. Just use the formula, right? Okay. Okay. So now what is n? N is 500. So what is p hat? P hat equal among 560, right? Then we have q hat, n p hat, we have everything. So what is this star? So this star, we need to check from the table. So this star is, so check from the table, right? Okay, so we want to find 92% confidence interval. Okay, so this is this star. Okay, so we need to check if this is 92, then 8% plus 4% here, 4% here, right? So we need to check all the way down. We need to check 9600. Okay, so we need to check 96. So from the table, we can find this cutoff point, this star, right? Okay. Okay. So for hypothesis testing, we say, so at this level we make our decision. So here is there enough evidence to reject the claim? So your answer can be yes or no. But we will not have those questions in the exam. So in the exam, because yes or no, you just say yes or no without do any work. You just answer yes or no. You have half a chance to answer correctly, right? So for me, I will ask you to find like a test statistic. Test statistic. And then maybe like critical value. So once we have those two important numbers, so we can determine the test statistic is small or big, right? If test statistic is small, then we believe no difference, or believe their claim is true. So if difference is big, then we reject the claim, right? So this test statistic is x bar minus mu 0 over, so here sigma or a's. Okay, so here we just can plug in like x bar. Let's say what the question says. X bar from a sample, so size 30, so n is 30, right? Find the average cost results. So x bar is 93.5 minus, what is mu 0? Mu 0 says should it be 95. The average 95 claim, right? Yeah, average 95. So this is mu 0. And so let's say, so here say, oh, this one is very clear. Tell us the standard deviation of the population thus. So this is sigma, yeah, 10.5 over n in 30. So we say this is z value, right? So from this z value, we can find p value or find critical value. So suppose this cutoff point, so this is z value. So here's 0, this z value is here. So this is p value or critical value. So critical value, we just check where is cutoff point of 0, 0, 5. So this is critical value. So we can compare critical value and test the statistic. We can make a decision. So here's one tail or two tail. So we say what we're talking about. We're talking about the cost. So cost is one tail, right? Okay. So for this problem, let's say we also wanted to find whether this. So the question is whether cost in this hospital and others have difference or no difference. So here we don't care high or low. So we just check whether they have a difference or no difference. So this should be two tail, right? Two tail. So here we just check cutoff point. So x bar, we say z value or t value x bar minus mu 0 over so sigma over radical a. So we put it to here. Okay. So x bar, let's say, so from this hospital, the average cost is this. So this is x bar, right? Yeah. So maybe you have to determine x bar first. This is x bar. And standard deviation. So this standard deviation sigma. So not, I'm sorry, this standard deviation is ace. So we say ace equal, not sigma, right? Because from sample, we find this. So x bar equals this. And what is the sample size? Sample size 35, right? Yeah. Okay. So what is mu 0? So mu 0 here we say the other people's average, other hospital average is this. So this is other hospital. Okay, and this is 3251 over, over radical 35. So this is a t value, right? So it's a t value. Okay. So then we determine this t value is big or not so big. So we need to compare critical value. So this critical value is okay. So at the first we will check t. So here we have cut. So this critical value depends on alpha. So alpha is 0.005. Then there's two tail or one tail. So here we should check two tail, right? We should check two tail 0.005. Okay, two tail. (0.005). We need to check that cutoff point, two tail 0.005, and the degree of freedom is 34. So if in the table, if we do not have 34, we just check the close one and think the close one is 30, so we just check 30. So like two tail degree of freedom 30, two tail 005. So we can find this critical value, right? So then we compare this critical value and this t-test statistic. So we can make a decision, right? Okay. Okay. So this one, let's say quite the same problem. Like we use this ARM 005 to judge whether the claim is true or not. So claim is the average salary is this. But from our sample, we find average on this. So here, this our sample, so n equal 20 and x bar is this. And the standard deviation, so this standard deviation is S. Like a sample of 20 knows is their salary has mean this and standard deviation this. So this standard deviation is S. Okay. So we found t value. So t value is equal to this. X bar minus mu 0. So mu 0 is this number mu 0, right? So mu 0 is average for all, or their claim is this. So and so this is right over n. So n is 20. So this is t value. Okay. Okay. So then critical value. So we just check. Okay. So the critical value is. So I think cutoff point here. Critical value is one tail, right? Because we're talking about salary. So high, so not high, right? So one tail. So we just check one tail 005 and degree of freedom, 19, right? So we can check the table, find this degree of freedom 19, find the cut point, so that critical value. Then compare the critical value with this test statistic. We can make a decision. Okay. So for these problems, type 1, type 2 error. So we have those kind of problem. Once we have the cut point, then we can determine, we can find whether this decision-making rule is good or not so good. Okay, so story just like that, right? We do the cut point 42. So in this case, we will accept HO. So in this case, we will reject HO. Okay. So what is alpha? So this alpha type 1 error. So type 1 error is we just reject HO when HO is true. So we plug in here. We reject HO when x bar larger than 42, right? So when HO is true, means when mu equal 40. Okay. So for such a probability, we need to know what is the distribution for x bar. So here we just plug it in, right? X bar follows this normal. So mean is 40. And sigma over n. So we need to check out what is sigma, what is n. So sigma, so let's just say sigma of 5, right? Sigma is 5. So what is n? N, take samples, sample size 36. Okay, so x bar follows us. So the problem become like x bar follows this normal distribution. We want to find this probability, x bar less than or larger than 42. So such a probability is easy, right? Okay. So then here, if we want to make a good decision-making rule, if we guarantee this alpha, we want to find the cutoff point. So here, from alpha, we want to find the cutoff point L. So let's say what is the decision-making rule? Decision-making rule is this: cutoff point here L. So in this case, if x bar less than L, we say we will accept HO. Larger than this cutoff point, we will reject HO. Okay? So we need to find L. So we say we guarantee alpha is 0.005. So this 0.005 is this probability, right? Probability for making type 1 L. So type 1 L is we will reject HO when HO is true. So reject HO means when x bar larger than this L, when HO is true, when mu equal 40. Okay? So when mu equal 40, we know x bar follows this normal, right? 40 and sigma, I think sigma is 5, right? N is 36. So x bar follows this normal. We want to find L such that this probability is 0.005. So we just need to find this L such that there's a probability x bar larger than L equals 0.005. So how can we find this probability? So changing this to standard normal, right? Changing this to standard normal. So L minus 40 divided by this 5/6. So this equals 0.005. So from the table, we find that the cutoff point. So the table, let's say. The table. This cutoff point. This is 0.005. So what is this number? So you can, from the table, you can find this. Okay. So this one, C is quite the same as B, but we're talking about the percentage proportion. So we just change the proportion. We just change those numbers to proportion. So we say when P hat, so here is P hat less than 0.47. So here, if this is 0.47, we will reject the claim. So claim is they will win. So here, actually, so let's say we just say half, right? So this is 50. So here we will reject HO, and then this part we will accept HO. So find alpha. So here we so alpha is reject HO. So reject HO is when P hat less than 47, right? We will reject. So when when their claim is true, like when we say, so here we can say like P hat is if there's less than 47, we believe he will lose the election. But actually, the chance is still half. We cannot say he will lose the election. Okay, so again, like find this alpha, so we need to know what is the distribution for p hat, right? So p hat follows this, right? P hat follows this normal. P, so we use the formula, okay? PQ, okay? Then plug in here. What is P? So P actually is 0.5, still half, right? 0.5, 0.5 over. So what is N? How many people we checked? Let's say we check 1,000 people. Okay. Yeah. Okay. Okay. So for find the top 2 error, we can only have those things, like only have the 2 points test. So possible P can be only 2 possible values. Either this one or that one. So we just say this beta is top 2. So what is top 2? Top 2 is we easily to believe other people. So meaning that we accept HO when H is not true. Okay. So let's say that when we will accept HO, when this, right? When X bar less than 24, we will accept HO. So when HO not true, so we have to pick HA. So if HO not true, so here we have only 2 options, mu equal 20 or mu equal 30. So here we have to pick mu equal 30, right? So these problems become like, we want to find this probability that so mu equals 30, so we need to know what is the distribution for X bar. So X bar follows this normal distribution, the mu, so it becomes 30, right? So sigma over radical N. So let's say here, let's check what is sigma. So let's check what is sigma here, what is N here. Sigma equals 5, N is 36, right? So sigma equals 5, N equals 36, so square root is 6. So such a problem is just to find a normal distribution probability. We know something follows this normal. We want to find this probability. So such a problem is also easy, right? Okay, so those are materials for exam 2. So I believe those exam 2 is also easy, and I hope everyone can get good scores. Okay, so we can stop here. Okay, so thank you.